Chair, and good morning to the attendants. I'm not Simisani Ndaba. I'm Mosweunyane, the third author there shown on the screen. Simisani is our student who I co-supervise with Dr. Thuma, who is also not here. So due to circumstances beyond our control, Ms. Ndaba couldn't come to present this, so I'm presenting it on her behalf. So the title of the paper is an empirical evaluation of writing style features in cross-topic and cross-genre documents in authorship identification. And the three of us are from the University of Botswana. So the outline of this presentation, I'll briefly touch on the introduction and then also touch on the related works. And then we go through the questions we asked ourselves while carrying out this research, and then go through the way in which we went through the research, which is the methodology, and then touch on the result analysis before concluding the presentation. So the essence of what we're looking into is that there will be different setups and circumstances where you come across documents or text, and you want to know who wrote it. So it's basically determining the writer of an anonymous text or a text which you don't know the author of. And there are various circumstances in which this is needed. Areas like information retrieval, in investigative journalism, or in law. For example, you might want to know the author of an anonymous email, or you want to detect plagiarism, or you want to catch a pedophile. So you have a text or a document which they wrote, and you want to determine if they wrote it. So the essence of determining this author of an unknown text is to base the decision on a written text sample that they actually wrote. So we're going to look for something that that person wrote, and then try to deduce the author's writing style. Try to extract the writing style features and compare them with those of the anonymous text and see if it can deduce whether the documents were written by the same author. This process is not smooth though, because the variation of writing style differs from text to text. And the author themselves might consciously or unconsciously vary their writing style from text to text. So you can't easily say this text was written by the same person if they have the right, you assume that they will have the right, the same writing style. And also the writing style might be affected by the genre of the area in which the author is writing, and also it's affected by topic variations. The writing style might differ from one topic to the other. So the assumption we had in this research was that if texts match in genre and topic, they will have the same personal writing style. But it's not true, obviously, for all authorship identification cases. It might differ here and there, but the realistic view is that usually you get authors who write across genres and across different topics. And also, while you want to determine the author of an unwritten text, of an anonymous text, you might also find that it's not possible to obtain text for that author in that specific genre or topic for which the anonymous text is. So you'll have to figure it out across a different genre and a different topic. So therefore, we'll have to find ideal writing style features that will help us to determine authorship identification for cross-genre and cross-topic documents. So for related works, for single topic and single genre documents, there are various authors who looked at this. Raju et al. 2017 looked at vocabulary richness He looked at the writing style features that make up vocabulary richness, and also other writing style features like number of letters, number of uppercase characters, digits, number of white spaces, and so on. And out of this, the writing style features have to have a representation so that you can fit them into the classifier. So in this case, he represented the writing style features using a vector, by a vector using the TD-IDF technique. And then when it comes to the classifiers, the Naïve Bayes, the support vector machine, and multiplier perceptron were used to build the different classification models using their different default parameters. And then for evaluation, they found that the area under curve, the AUC of 0.92 was the one which was the best with the SVM model. And then there was Louis et al. In 2017 also, they looked at various writing style features, like number of unique words, vocabulary richness, word n-grams, and so on. And then also, similarly, they used the Naïve Bayes method, the SVM, and the decision tree, and also added multi-nominal logistic regression. And then they found the best performing one was the one with the highest AUC of 0.85 with SVM. Still on single topic, single genre, we looked at Mora and Vogel on 2013. They looked at n-gram patterns from lexical tokens, unigrams, bigrams, character for n-grams, and syntactical post-unigrams and trigrams. And then similarly also used similar classifiers, SVM, logistic regression, decision trees, and the Naïve Bayes. And then also they looked at the lexical n-grams and saw that they outperforms post n-grams. So, but then, like we said, the writing style features that we are going to work on, we're looking for cases when it's cross-topic and cross-genre. So the authors who did this also looked at a variety of writing style features that they could use, and the features were from a variety of groups: lexical, syntactic, structural, and content-specific features. For lexical features, for example, for this author, Sue, in 2017, he looked at lexical features like frequency of digit characters, frequency of white space characters, and frequency of alphabetic characters. And then for structural set, they had measures that quoted content including use, email, and telephone. And then for classification techniques, they used 8 techniques. That is, 4 of them were base learners, and then 4 were random subspace that were actually based on the 4 base learners. And the method they took was using the feature sets in an incremental order. So they took one feature and then took the first feature and added the second feature, and then added the third feature, and so on. So they built it incrementally in order to evaluate whether those features work well in cross-topic and cross-genre. So the lexical, syntactic, and structural and content feature set combination was the one that gave the best combination, and with SVM, and the result was an AUC of 0.945. So what we asked ourselves when we were looking at these past works was that they used writing style features, and first we presented those that used or the authors who previously used single genre and single topic writing features, and we asked ourselves if those could be applied to cross-genre and cross-topic evaluations. And then when we looked at those also, we saw that there were authors who looked specifically at cross-genre and cross-topic writing style features. And then we ask ourselves in our research, which ones work best and which ones cannot actually be used on cross-genre and cross-topic authorship evaluation, authorship identification, sorry. And then because one of the authors actually used a combination of features, we wondered whether we could also combine the features and then try to get to see which ones work best on cross-genre and cross-topic evaluation. So the data set that we used, we simply borrowed the corpus from the Uncovering Plagiarism, Authorship and Social Software Misuse conference. That's the CLEF conference of 2015. The data set contained 100 sets of text, and each set contained a known author document and an unknown author document. So those covered different topics and different genres. There were things like poems, there were dialogue lines from plays, and there were passages from books. So the texts were actually short with an average of 350 words per document or per text. And the usual way of data preparation was followed with text pre-processing, like tokenizing, normalizing, stemming, to speed up the data and prepare it. And then the representation, that is actually the getting of the writing style features from the text. We use the numeric value, where the difference between the known and unknown documents indicated whether the documents were written by the same author or not. And then if the known and unknown text features were most likely, the known and unknown text were most likely written by the same author, we get a positive value of over 0.5. And if they are most likely different, written by different authors, we have a negative value under 0.5. So the experimental setup, the evaluation experiment used Worker, which has classifiers for data mining tasks. The classifiers selected for the experiment are random forest, decision tree, and Naïve Bayes, which builds a probabilistic builder. The reason for choosing these classifiers, of course, were that they are well-known and popular supervised learning algorithms. And then the classifiers, the parameters have to be changed to obtain optimal classification accuracy performance. So for this, we use a cross-validation technique to find out how well the classifier uses the training data to accurately categorize unknown data. The data set was divided into a training set, which was made up of 66% of the data, and the remaining 35% will be the test data set. So for this, we use grid search for selecting the values for the parameters that maximize the accuracy of the model. So the procedure of grid search was indicated by Sue et al. In 2015. So we borrowed that one to on cost and loss parameters, and also applied the tenfold cross-validation method. So the training set and the test data are used to find a pair of optimal parameters, which are cost and loss parameters of the RVF kernel function. The pairs of the parameters are tested in intervals, step by step as part of the grid search. And then we choose the pair where the error of cross-validation is minimal and with a high accuracy cross-validation. So the ideal cost and loss pairs were found to be 1.0 and 1.0 for both cost and loss. For the cost and loss pairs are 0.1 and 1.0 and 1.0 respectively. So in the random forest classifier, the number of trees and the number of randomly parameter pairs that were used were also tried and tested to find an optimum parameter pair. So it was found that the different number of trees and the number of randomly pairs used in the experiment were 0, 1, 0, 2, 1, 1, 1, 2, and 4, 3. And then for evaluation, empirical evaluation of the result, we used sensitivity, specificity, accuracy, ROC, and Kaplan coefficient to just briefly divide them. Sensitivity measures the proportion of actual positives that are correctly identified. Specificity measures the proportion of actual negatives that are correctly identified. And then the accuracy measures approximates, the accuracy measure approximates how effective a method is by the probability of the true value of a class label. And then the kappa coefficient assesses the proportion of agreement between two or more methods for categorical items, while the ROC or AUC will determine the ability of a classifier to rank scores appropriately. That is the proportion of sensitivity and specificity. So these are the writing style feature categories that we used. So for lexical, we looked at uppercase frequency and character count. And then the character feature sets, which are unigrams, bigrams, trigrams, and quadgrams. And then word length over hapax, length numera, type of token ratio. For syntactic ones, we used part of speech tag, which unigram, bigram, trigram, and quadgram, and then punctuation, unigram and bigram, and function weight. For structural features, we used paragraph frequency and sentence length, and for content, we used common words in terms of words, unigrams, bigrams, and telegrams, trigrams. So the results, like we said in the research questions, we looked at to answer the research questions to say which type of writing style features work best for the individual ones. We looked at which writing style features identified from the previous work could be used, but that was single genre and single topic, and then they could get us effective results. So when we do that, for syntactic, the syntactic one stood out with an AUC of 0.738. Of course, still lower than what the other authors in single genre and single topic used, but significant enough to be reported. And then we looked also into adding features one by one and removing them, what we call an ablation process. So what happens is that we take one feature, we add another feature and remove it and see whether the results improved or actually got worse with the removal of the feature. So when we do that, we build on the lexical features, the syntactic features, the structural and content features. We saw that still the syntactic features were the ones that performed best with an AUC of 0.750. Now, the other issue could be that we could take the features and then combine them. We could take the feature groups and then combine them and see which ones work best for cross-genre and cross-topic. And we took the lexical and syntactic, lexical and structural and so on, keep building them up to see which combinations work best. And if you see at the two screens, you see that the AUC of 0.751 for both, with both the Naïve Bayes and the random forest for lexical and syntactic combinations was the one that worked best. And by this time, we could see that the syntactical features are the ones that feature more in terms of giving the best results. And then also with the combinations, we could also use the ablation process, that is, add the feature and also remove them to see if adding them improved the results and removing them deteriorates the results. So with that also, we looked at the different combinations we looked at before, and we kept adding and removing features and seeing if those would give us good results. And the lexical and synthetic features with a random forest were the ones that gave the best result with 0.821 of AUC. And the lexical, syntactic, structural, and content also gave a very good figure with 0.837 AUC. So what we got from this, or what we learned from this experiment, is that syntactical writing features work best, were the most successful ones as an individual set for cross-genre and cross-topic authorship identification. And then the combination of lexical, structural, content, and syntactic, or syntactical and content combination feature sets also work best because they gave the highest AUC results. So what we learned from this was that the results show that if we have syntactical writing features somewhere, we could we usually get the best results for cross-author and cross-genre authorship identification, as well as having lexical and syntactical features. Of course, if syntactical features feature everywhere where we have the best results. So we could use that syntactical writing features work best for cross-genre and cross-topic authorship identification. And then the individual ones, we actually found that the post features, which are the unigrams, bigrams, trigrams, and quadgrams, are the ones that give us the best results. And punctuation bigrams also work best with cross-feature, cross-genre, and cross-topic identifications. And then for the combinations, the particular features that could be tried further are character-based n-grams and word-based writing style features, such as post n-grams, common word, sentence length, and word n-grams. So what you could get from this is that the further experiments could be conducted using these writing style features to find out how best they work, but using different data sets, since we can make our conclusion based on just using a single feature set, a single corpus, or single single set of documents. Thank you for your attention. Questions, if you have any.